In the previous class, we learned what 5G is, and we learned about some of its applications. Today, we will discuss telecommunications standards. You may be wondering why it's important to learn about them. Well, what are used for? Let's take a look. First of all, we need to understand what exactly a telecommunications standard is. These standards are the technical specifications that must be complied with when producing telecommunications products. They are involved in every aspect of the industry. You may be wondering, why do we need these standards? Well, let's consider this imaginary mobile network where Zhao Hua wants to call his friend, Zhao Ai, to plan a weekend tour of Hangshao's scenic West Lake. Zhao Hua loves the national brands. He uses a Huawei mobile phone, but Zhao Ai is a cosmopolitan young woman who loves her international brands. She uses an iPhone. To make the phone call, the connection has to go through base stations connected to a core network. The base stations and the equipment used to build the core network are not necessarily all provided by the same vendor. For example, the base station could be from Huawei, while the core network is built from equipment from other manufacturers. How can we ensure products from different vendors can still interconnect? These products are developed based on predefined standards, and these standards ensure that the devices on the network can interconnect and that they can work together. Because the devices we use conform to mobile communication standards, when we travel abroad, we can still use our own mobile phones to access wireless networks when we are abroad. These standards make international roaming, WeChat, and other forms of social networking possible while we are abroad. So these standards are extremely important. Now, let's take a look at the critical role played by mobile communication standards in the life cycle of a mobile network. Communications technology is a relatively complex closed system. Each new generation of telecommunications technology starts with the International Telecommunications Union, or ITU. All of the major companies and organizations involved start researching the new technology. They test the practicality of the new technologies and propose standardized solutions, and standards organizations select the most appropriate options and define them as the new standards. After that, each equipment vendor can develop corresponding products based on standards and sell their products to the network operators for deployment and to provide communications services. Communications technology standards define the industry. Whoever controls the standards controls the industry. Now we know why communications networks need standards and why these standards are so important. Now, let's take a look at one of the ways standards affect how the industry develops. In the 3G era, the US company Qualcomm had mastered key CDMA technologies and actively promoted these technologies to form standards. They also applied for global patents to establish patent barriers. Any other company developing 3G products, including core network devices, base stations, or mobile phones, had to comply with the new 3G standards. And some of the CDMA technologies used for 3G standards were patented by Qualcomm. Any one company wishing to use these technologies had to pay Qualcomm for their use. Qualcomm's significant stockpile of 3G-related patents not only helped Qualcomm, it hurt their competition. It cut into the profits any other enterprises who were part of the production chain. Later on, this held back the development of standards organizations such as 3GPP2, which has been established by Qualcomm. In contrast, today's more open and inclusive 3GPP is growing strong. So, with standards as important as they are, who gets to define the standards for 5G? Currently, ITU and 3GPP are two very important international standards organizations in the field of mobile communications. The ITU defines the vision for 5G, the network KPIs, and the 5G network requirements. The 3GPP is responsible for standardizing the technology. They define and release the technical specifications to the public and produce technical reports. 3GPP is working with major equipment vendors and telecom operators to formulate 5G standards. 3GPP is a standards organization established in December of 1998. They are one of the most important mobile communication standards organizations. Its members include regional and national standards organizations, along with major equipment vendors and telecom operators. 3GPP standards evolution started with GSM. The standards evolved from 2G to 3G, and from 4G to 4.5G. The corresponding protocols evolved from R99 to R13 and R14, and 5G standards are currently under development. As an international standards organization, 3GPP has to consider the wide range of problems that can result from inconsistent standards. The inconsistency between 3G and 4G standards created problems for the development and deployment of all sorts of products and services. This is why 3GPP is proposing unified global 5G standards right from the start. They want to give full consideration to the challenges of global roaming and to take full advantage of economies of scale. The goal of the 5G industry is to establish a global standard. Now, let's talk about the 5G protocols themselves. The 5G protocols start with 3GPP release 15. To protect legacy LTE investments of telecom operators, 5G will include two parts, LTE Evolution or eLTE and the new 5G Air interface. NR, eLTE and NR standards will be defined in 3GPP release 15 and release 16. eLTE will be an important transitional technology as 5G is not yet ready for commercial deployment. However, the course focuses primarily on NR. Now, let's learn about the development of 5G standards. The development of 5G standards is a complex undertaking, but we need to get to market as fast as possible. To that end, 5G protocol development has been divided into two phases, 5G Phase 1 and 5G Phase 2. These two phases correspond to two related protocol releases, R15 and R16. The standards related to eMBB have been defined in Release 15 and the protocol was frozen in June of 2018. Release 16 defines two scenarios, mMTC and uRLLC. The Release 16 protocol will be frozen at the end of 2019. 5G standards can support a wide range of services scenarios like eMBB, mMTC and uRLLC, and we expect to see commercial deployment worldwide by 2020. The mobile communications market is huge. It's so big, in fact, that Verizon, a US operator and founder of the Verizon 5G Technology Forum, or V5G, joined hands with forward-thinking carriers in Japan and South Korea, KT, NTT Docomo, and SK Telecom to establish the 5G Open Trial Specification Alliance, or OTSA. In July 2016, Verizon announced the completion of 5G wireless standards and their plan for pre-commercial deployment in Q1 of 2018. OTSA does not represent an international standard, so it may result in 5G standards that are not unified globally, which would split the industry chain into separate branches. In response to competition from OTSA and to accelerate development of new 5G air interface technologies on existing mobile communications networks, at MWC 2017, 3GPP agreed on a plan to accelerate the development of 5G standards. 5G Phase 1 has been divided into two parts, Phase 1.1 and Phase 1.2, which correspond respectively to independent networking in non-standalone and standalone architectures. Phase 1 protocols are frozen in December of 2017. This version, the non-standalone architecture, does not support independent networking. It needs to be used together with 4G to facilitate rapid deployment of 5G services by forward-thinking communications companies. Phase 1.2 was frozen in June 2018. In Phase 1.2, where standalone architecture was defined, the 5G network can be deployed independently. It does not depend on the 4G network. During MWC 2017, multiple operators and equipment vendors, including Docomo, KT, SKT, Vodafone, AT&T, BT, DT, Qualcomm, Intel, Nokia, Ericsson, and Huawei, announced their support for the acceleration of 3GPP 5G standards development. At this point in time, OTSA has actually already been disbanded. In this lesson, we took a look at the 5G international standards organizations and reviewed the progress of 5G standardization so far. In the next lesson, we will discuss 5G network architecture and the current trend towards complete cloudification.